Alrighty, hello. We are back again with another state test review video. Today we're talking about standard S.ID.7. Here we go. Question 1. Juan wants to rent a house. He gathers data on many similar houses. The distance from the center of the city, X, and the monthly rent for each house, Y, are shown in the scatter plot. Juan models the data with a linear equation. Based on the scatter plot, what could the number 1275 represent in this equation? So, 1275, you can see that this x-axis only goes from 0 to 12. So 1,1275 would have nothing to do with this. However, our y-axis goes all the way up to 1,400. 1275 itself would be about here. What could 1275 represent? The estimated rent for a house in the center of the city, the estimated minimum rent for a house far from the center of the city, the estimated change in rent for each additional mile from the center of the city, or the estimated change in distance from the center of the city for each dollar change in rent. D makes no sense to me. That would mean that if your dollar changed by $1, you would then move 1,275 feet away from the center of the city. That makes no sense. The estimated change in rent for each additional mile from the center of the city. That would mean that if you moved 1 mile, your rent would change by $1,275, which we can see is just not true. Our range is somewhere around $1,400 down to somewhere around $600. So having a $1,300 change just makes no sense. So that leaves us with A and B. The estimated rent for a house in the center of the city, or the estimated rent for a house far from the center of the city. Our x-axis represents the distance from the center of the city. So something at an x of 0 would be right smack in the middle of the city, while something like at 10 would be 10 miles away from the center of the city. 1275 hovers much near the top of the data, right next to this spot right here, which is an actual point of data. And to compare it to the rest of the data, as you get farther from the city, it is ridiculously far away from the other rent numbers. So I would say that this would be the estimated rent for a house in the center of the city, which is A. Number 2. The population of a town has grown by an average of 2,000 people per year over the last 10 years. Which equation could represent an appropriate linear model? It's grown by an average of 2,000 people per year. Okay? People per year. When we talk about ratios, and we talked about ratio proportionality back in 7th grade, we talked about ratio proportionality being y over x. Miles per hour, people per year, cost per donut, So people would represent your y, year would represent your x, okay? When you see per, you think of slope, or you think of rate of change. So the 2,000 people represent your rate of change, which is your slope, which means that it's going to be right next to a variable. So we're looking for an answer that has a 2,000 right next to a variable. A does not, C does not. B does, D does. What's the difference? D has a negative 2,000, meaning that it's actually shrinking by 2,000 people per year, while B has 2,000x, which is positive 2,000, implying that it is growing by 2,000 per year. Therefore, B. Question 3. This is a long question. It's going to be hard to fit all this on the screen, so I'm going to try my best. Colin purchases a plant from a gardening store. The height of the plant in centimeters after different numbers of weeks is shown in the table. The height of Colin's plant in centimeters can be modeled by the given equation, where h is the height of the plant and w is the number of weeks since he purchased it. On the same day that Colin purchases his plant, Megan purchases a plant that has a different height than Colin's plant, and that grows faster than Colin's plant. Megan also uses a linear equation to model her plant's growth. Complete the sentences to describe the equation that can model the height of her plant. Okay. So, her plant, okay, Megan purchases a plant that has a different height than Colin's and grows faster. The rate at which it grows is faster. If it grows faster, we hear faster rate. And when you hear rate, you think slope. So if it grows faster, that means it has a faster rate, which means it has a higher slope. The slope in Megan's equation must be greater than the slope in Colin's equation. And we know that it must be greater than because it specifically states that her plant grows faster. The y-intercept in Megan's equation can either be greater than or less than, must be greater than, must be less than, must be equal to. All the information that we get about her plant is that it starts at a different height. That's all we're told. We're not told if it starts at a smaller height. We're not told if it starts at a larger height. We just know it's different, which means it can't be equal to. But if we don't know if it's larger or smaller, we can't definitively say it must be greater than or it must be less. We can't definitively say this choice or this choice. We just know it's one or the other. It can be either greater than or less than the y-intercept. Because remember, the y-intercept represents your starting point. Question 4. A plot is shown relating the number of vehicles using alternative fuels to the number of years since 1992 based on the equation of the line of best fit for the data, which statement is a valid conclusion. I'm going to rewrite this line of best fit real fast so that it's more visible. Is that a comma or a point? That's a comma. Because even I'm having trouble seeing it. Okay. We've rewritten it. It's better. Okay. So, is it based on the equation of the line, which is a valid conclusion? A. The average number of vehicles using alternative fuels in the United States from 1992 to 1999 was approximately 18,891. That would mean that the amount that it grew was only 18,000, which we can very much see it's not. This went from under 300,000 to over 400,000. Not A. The increase in the number of vehicles using alternative fuels in the United States every year varied from approximately 18,891 to approximately 275,763. This is getting closer. We have the fact that it is in the United States every year. Remember, we love hearing every year when we're talking about rate of change. However, this is insinuating that the slope gets as high as 275,000, which the slope is not. The slope is constant. So, the slope can't change. The number of vehicles using alternative fuels in the United States increased from approximately 18,891 to approximately 275,763. This is insinuating that in 1992, which would be the y-intercept of the graph, the y-intercept was 18,891, which you can see very hilariously, it is not even close. So then it must be D, if we've done this right. The number of vehicles using alternative fuels in the United States increased from approximately 275,763 in 1992, insinuating that that is our y-intercept, which it is, by approximately 18,891 every year up to 1999, which that is our slope. That is our correct answer. It increased from the y-intercept every year by the slope. Exactly what you want to see. Kingston researched the amount of rainfall in the town during the month of September. He found that the total amount of rainfall Y in inches that had fallen by a given day X could be approximated by the given linear model. According to the linear model, what is the best approximation for the rate of change in inches of rainfall per day in September. So what this is asking you to do is to figure out what the slope is. So this equation is in what's called standard form. Standard form AX plus BY equals C. Okay, granted this would be more of BY minus AX equals C, but it's the same idea. We need to get this into Y equals MX plus B format, meaning that we need to solve for Y, so we need to get Y by itself. How are we going to do that? 2y minus 6x equals negative 5. Well, if I need to get y by itself, the first thing I need to do is get rid of the addition and subtraction next to y, which is this negative 6x here. How do I do that? I move it to the other side of our fence by adding 6x to both sides. Negative 6x plus 6x makes 0. That leaves us with 2y equals 6x minus 5. These two cannot combine because they are not like terms. This has an x, this does not. Last step, I need to divide everything by 2. 2 divided by 2 makes 1, so that just leaves us with y. 6 divided by 2 is 3x minus 5 over 2. I'm not going to put that into a decimal. I'm just going to leave it as it is because that's not important. What is the best approximation for the rate of change? The rate of change is our slope. Our slope at this point is 3, so the answer is 3. You're just converting it from standard form to y equals mx plus b, and that's it. All right, so that's going to do it for this video. I hope it helped. If you have any questions, please let me know. Otherwise, good luck on your state test.